having velocities of 0.5 meter per second and 0.3 meter per second respectively collide elastically in one dimension. The velocities of B and A after the collision respectively means they exchange their velocities. Why? Because both masses are identical. Okay, if masses are identical after collision, they exchange their velocities. Means suppose it is a A ball and this is B ball. A is moving with the velocity 0.5 meter per second. Okay, so B is moving with the velocity. So it is the direction is when you take like this. So you have to consider it minus, right? So minus 0.3 meter per second. 0.3 meter per second. Here direction. So both are coming close to each other. Why? Because it's a one-dimensional collision. Both are approaching nearer to this. So zero point 0.5 and zero point 0.3. So when they after collision, what happens? And A takes the velocity of B and B takes the velocity of A. Then after collision, A takes the velocity minus 0.3 meter per second and B takes the velocity 0.5 meter per second. They have asked for velocities of not A and B. They have asked for B and A. Here B is 0.5 and A is minus 0.3 meter per second. So which answer is matching here? Answer B is matching. On a frictionless surface, a block of mass M moving at a speed V collides elastically with another block of same mass M which is initially at rest. After collision, the first block moves with an angle theta, and this is angle theta, to its initial direction and has a speed of v by 3. The second block speed after the collision is. Okay. Here we represented in this figure, right? So first block moves with the velocity v and it collides the second block which is at rest. After collision, the both the blocks moves with some angle theta with the horizontal direction. And the first block moves with the velocity v by 3 after the collision. We need to find the velocity of the second block after collision. Okay, so it is given that this collision is elastical means kinetic energy before and after remains same. Use that formula, kinetic energy, conservation of kinetic energy by based on that formula. So you please solve this question. Before kinetic energy, before collision, the collision before kinetic energy, collision before kinetic energy is equal to collision after kinetic energy is same for elastic collision. Collision before kinetic energy. What is the formula? What is the formula?
M1 plus M2.
Yes, that is half m. What is the first block? It is moving with the velocity v square. It is the first block. And when you come on the second block is at rest. For rest, the kinetic energy is 0. Okay. The kinetic energy you consider for the resting block, so that is 0. Now after collision, and the first block moves with the angle theta with the velocity v by 3. Okay. So after the collision, what happens? The first block moves with the velocity how much? V by 3. Here velocity you have to consider V by 3 square. V by 3 whole square. Consider here V by 3 whole square. And we don't know the second block velocity. So let us assume that is V2. We need to find the value of V2. Up here clear everyone? Both side you take common half. Half get cancelled. Both side you take half as a common. And both side get cancelled. All m's get cancelled. You take m common and get a cancel. And whatever the remaining things we have here, v square equal to v square by 9 plus v2. Okay, so you solve this, then you will get the v2 value here. Okay, so what is v2 you will get here? I am doing here. So v square equal to v square by 9 plus v2. Then v square by 9 you take it this side. It will become minus v square by 9. Yes or no? Minus v square by 9. Yes. Okay, I forgot here. So v2 square. You write v2 square here. v2 square. 9 into v square minus v square by 9. 9v square minus v square is how much? 8v square by 9. So here v2 square is there. So when you take it here, it will become root. What is the root over 8? 8 we can write as 4 into 2. Root 4 value is 2. Then 2 root 2. Square root get cancelled for v. Root 9 value is how much? 3. So your answer, which one is matching? 2 root 2 v by 3. Your answer C is matching. Two particles of masses m1 m2 move with initial velocities u1 and u2. On collision, one of the particles gets excited to higher level after absorbing energy E. If final velocity of the particles v1 and v2, then we must have. So now you see, according to law of conservation of energy, the collision before kinetic energy, collision after kinetic energy remains same. So kinetic energy before collision, kinetic energy before collision you find out. Okay, kinetic energy after collision, they should be remains same. Kinetic energy after collision. Okay, kinetic energy before collision, both particles has mass m1 and m2 and moves with the velocities u1 and u2. Find out the kinetic energy formula is half m u square, right? Half m u1 square, m1 u1 square plus half m2 u2 square, which is equal to half m1 v1 square plus half m2 v2 square. Now you see, after the collision, one of the particle absorbs more energy. The energy term you write here. The energy term you write here. Okay, this plus E, when you take it this side, it will become minus half m1 u1 square plus half m2 u2 square. That plus E, when you take it this side, it will become minus C, minus C. Now you see which one is matching answer here? Half m2 v2 square. So which one is matching your answer?
Option A, sir.
Option A is matching. So answer A is right answer. Two spheres A and B of masses m1 and m2 respectively collide. So A is at rest. All of you please see this diagram also. A is at rest and initially A is at rest and B is moving with the velocity v along the x-axis. Already they given the direction also. They move along the x-axis. After collision, what happens? B has a velocity v by 2 in this direction. You see this is the y-axis. The B moves in the y-axis direction with the speed v by 2. Okay, to the original direction. The mass A moves after collision in the direction we don't know. Now B moves along y-axis direction with the velocity v by 2. We don't know the direction of the ball A. So where it will move. So let us assume it is moving along this direction. It is making angle theta with the horizontal x-axis. Okay, we need to find the direction of the ball A. Okay, so you apply the law of conservation of momentum along x-axis. Law of conservation of momentum along the x-axis. So along x-axis, apply the law of conservation of momentum. Momentum before collision, momentum after collision. Momentum means mass into velocity. What is the velocity of mass ball B? Yes, that is m2. What is the velocity given here? So this is m2. The ball B has the mass m2. Ball A has the mass m1. And this is m2 and this is m1. Now you tell here along the x-axis, momentum for ball B is m2 into v for ball B. For ball A is at rest. For rest, there is no momentum. Momentum of the ball A is rest before collision. Then after collision, what happens? Is there any after collision? Along the x-axis direction, is there any ball is moving? The ball B is moving along y-axis direction, but along x-axis direction, the ball B velocity is 0. But the ball A moving this direction, it is making angle theta with the horizontal. Then how do you get this x-axis here? This is, we can get here hypotenuse into cos theta. Okay, along the x-axis direction, the ball A velocity is v dash cos theta. Okay, v dash cos theta. You write here. V dash cos theta. Already you know this, right? Along the adjacent to the theta is hypotenuse into cos theta. Other side of theta is hypotenuse into sin theta. Okay. The direction of the A along the x-axis and y-axis. Along the x-axis you consider here. Along the x-axis how much it is? V dash cos theta. How much it is? V dash cos theta. Okay. So finally we will get here. So m2 into V equal to m2 into 0 is 0. So m1 V dash cos theta. Okay. So cos theta equal to what will you get here? Cos theta equal to m2v by m1 v dash. Okay, this is the cos theta value. Similarly, you find the conservation of momentum in along y-axis direction. Along y-axis direction, find out. Along the x-axis direction, already we got this cos theta equal to m2v by m1 v dash. Now you see along the y-axis, along the y-axis, along the y-axis, before collision, both balls are moving in the x direction. If there is no motion in the y direction, before collision, both spheres, means both of the spheres lies in the x-axis direction only. Here B is moving, A is at rest. Is there any movement in the y-axis direction before collision? No. So before collision, there is no movement in y-axis. After collision, the B ball moves with the velocity v by 2 along y-axis direction. So the ball B has the mass m2 and it has the velocity v by 2. m2 into v by 2. Now you see the ball A along y-axis direction, what is its velocity? m1 into along the y-axis, what is its velocity? V dash sin theta. So m1 into v dash sin theta means the ball A, velocity of ball A splits into two directions, x-axis and y-axis. Along the x-axis, hypotenuse into cos theta. Other side of that is y-axis, hypotenuse into sin theta. V dash into sin theta. From this you get the sin theta value. From this you will get the sin theta value. So this m2v by 2, you take it this side, it will become minus m2v by 2 is equal to m1 v dash sin theta. Okay, so you make sin theta separate. So sin theta equal to m1 v dash. Here when you take it this side, so it will become in it will come to the denominator, that is 2 m1 v dash. Now what you have to do? This is a expression 1. This is the expression 2. To get the tan theta, sin theta by cos theta, already you know that is tan theta. So what I am doing, I am dividing equation 2 with equation 1. Sin theta by cos theta, sin theta by cos theta. What is expression 2 we have here? Minus m2v by 2m1 v dash whole by, what is the cos theta value we have? m2v by m1 v dash. Now you see in m2v get cancelled, m1 v dash also get cancelled. The remaining thing we have here minus 1 by 2. That sin theta by cos theta is how much? Tan theta. Tan theta equal to minus 1 by 2. Then theta equal to tan inverse of 1 by 2. Okay, this is your answer. Okay, that means the ball A moves with the angle tan inverse of minus 1 by 2 to the x-axis. So here which one is answer matching here? Answer D is matching. Okay, just you put here minus. So theta equal to tan inverse of minus 1 by 2 to the x-axis.